This video shows how you can use the VEDAViz portal to explore the 50 sensitivity runs that have been done with the Romanian TIMES model. Now, when you enter the portal, this is the view that you will see, which basically shows the reference case, electricity generation mix on the left side, and the CO2 emissions from electricity and heat generation on the right side. So if you move your mouse, then you can see the different technologies. So this is coal CHP existing, so -E is for existing. This is coal electricity existing, so this was CHP, this is pure electricity, this is gas CHP, hydro, nuclear, oil and wind. So the new technologies come basically later on, because I've assumed the utilization factor or the availability factor to increase over a few years. So the new capacity is really required later on, which is mainly gas in this case. So this is the reference case, and the sensitivity was basically done on gas price and CO2 price. So to see those scenarios on this chart, you see the alternative gas prices that have been used. So the top curve is the reference case gas price. This is in euros of 210 per gigajoule, and it has been assumed to reduce to about 60% of the current prices, so in steps of 10. So 1, 0.9, 0.8, 0.7 and 0.6. And these are the CO2 price trajectories that have been used. So from $10 to $300 and increasing in this way. So 10 into 5, 50 runs have been done. So now to see, let's say we want to see what happens if the gas price reduces to 90% of the current prices. So you have to click this button here, and you see, as you would expect, there is a little more gas, but only towards the end. Nothing much changes, actually nothing changes before 2035. Another reduction to 80%, same story. Now you start seeing changes in 2030 as well, and some changes here. So basically you see some coal being replaced by gas as the price falls. Now let us see the impact of carbon prices. The changes definitely will be much higher. So with $10 you see some more gas, 20 still some more gas, 35 now you see coal really starts to go down from its earlier levels towards the end. 50 coal almost goes to zero by the end. It's all new gas starts dominating. At 75 bio comes in after 2035. At 100 bio comes in a lot earlier. At 150 bio comes, but now we have this new thing which is offshore electricity, offshore wind. And at 200 you see bio coming earlier and coal going out even earlier and offshore wind penetrating even earlier. And then at 300 you see some more of that stuff. Now this is good, but it can be made even better if we could see the substitutions more directly, right? Because here we had to guess that this is going out, that is coming in. So for that I have this button where instead of seeing the absolute values, you can see the difference from reference for any case. So for example, if we go to this view, which is $10 tax, and we now click on ref diff, now this is showing differences from reference. So we see that starting in year 2035, about 4 terawatt hours of coal electricity is replaced by new gas. Now another thing you can do to make it easier to see the changes is to scale these charts. Okay, that you can do from here. Activate scaling. So now the scale will not change as the charts change, so that you can see the relative impact of things. So, and remember that 55 terawatt hours is the electricity consumption in the base year. So just to give you a sense for the numbers. So now these are small changes for $10. Now you go to 20, this thing becomes more significant. Same dynamics. 50 again. Now at 75 you see biomass coming in, and at 100 you see biomass coming earlier, and 150 you see offshore wind, and so on. So you see now precisely what is going out and what is replacing it. And then you can see that at this price, what is the impact of cheaper gas. So you see that if gas were cheaper, then instead of offshore wind, actually some gas turns out to be a part of the optimal solution. And as it becomes cheaper, of course, some biomass also goes out. Now the last thing, which may be a little complicated, but you can also see the impact of gas price. Okay, just gas price. So for that I have this gas diff, which will actually show you what happens at this price just because of gas. So instead of subtracting the reference scenario, here I've subtracted the 150 scenario with gas price reference. So this is available only for the cheapest gas price. So now you can see what happens with cheap gas if the carbon price is low. So there's more gas, less coal. More gas, even more gas, less coal. And this actually we would expect to peak at some point, because beyond a certain carbon price, gas will not be playing a role anyway. So gas becoming any cheaper will not really help. So you see now at $35 gas was playing a big role, but beyond 35 it sort of fades away. But then it is playing a role to substitute biomass. See, that's interesting. Earlier on it was substituting coal, but now at this point it substitutes biomass, and then it does some more of that, and then again as the carbon price goes higher, the role of gas reduces, but then it does that with wind. So basically each time there is a new technology in the solution, gas tends to make a dent in it before that technology starts dominating. Okay, that's it.